Welcome to the Open School, a school where teachers all around the world help students all around the world. Question 1. What will be the surface of a sphere of radius 3 meters centered around the light bulb? So the area of the sphere is 4 pi r squared. So that is 4 by pi, and the radius was 3 meters, so 3 squared. So that is 4 by pi by 3 squared, 9, so 36 pi. And this gives me 113 meter squared. Question B is quite simple. How much of the power of the light is received by the surface of the sphere? Well, all of it. Yeah, you have the bulb. Every second it emits 50 joules that's spread out and reaches the sphere. So every second the sphere receives 50 joules. That's 50 watts. Right? So the power emitted by the lamp is the same as the power received by the sphere. 50 watts. So what is the power received by 1 meter square of the sphere's surface? For that you can use the formula for intensity. Power divided by area, and we have the values. So it's 50 divided by 113. That's 0.44 watts per meter square. You can apply the formula, but you can also think a bit, if you want. You can say, okay, the intensity is the energy received per second for 1 meter square. So it's going to be the power emitted by the lamp multiplied by the fraction of surface corresponding to 1 meter square, which is 1 meter square divided by the whole area, by 113 meters square, because 113 meters square receives the 50 watts. So 1 meter square will receive 1/113th. You can think that way too. You choose. Yeah? Okay, let's do a last exercise. What we've seen in the previous exercise is that when you have a punctual source of light that emits light in all directions, well, if you have a sphere around it, you can calculate how much power received by 1 meter square of the sphere. So you've got your light here. You have a sphere around it, got a radius. So the intensity of the light, the power per meter square, is the power of the bulb, of the light, divided by the area of the sphere. Now, we could consider the sun like a punctual point of light, right? It's like a big light bulb. So you've got the sun here that emits light in all directions. The sun is a star, but it's also a source of light. What turns around the sun? Well, planets. And one of them is our planet. It's the Earth. So you can imagine the Earth here, turning around the sun. And the Earth is at a certain distance from the sun. If I want to know how much light I receive from the sun per meter square at the level of the Earth, I can use the same formula. I equals P divided by 4 pi d squared. 4 pi d squared corresponds to the sphere around the sun that has a radius corresponding to the distance between the sun and the Earth. So this is the subject of the next exercise. Let's check it out. The luminosity of the sun is 3.9 10 to the 26 watts. 3.9 10 to the 26 watts is the luminosity. That's the name we call for power when it's about a star. We say the luminosity of a star is, and this means the power of the star, basically. It's just an astronome way of saying power. The astronomers call it like this. The first question is to calculate how much energy is emitted by the sun in 1 year. Okay. So remember that power is the energy transferred divided by the time, per unit time. So I can write the energy is the power multiplied by the time, because I just multiply by time on both sides, and I end up with E equals PT. So, what time should I put? It's 1 year, but I need to put the time in seconds. So let's calculate the time in a year, in seconds. So I'm going to go to the main screen. How many seconds in a year? Well, in a year, there's 365 days, right? Each day has got 24 hours. And each hour has 3,600 seconds. So the time of a year is, in seconds, 365 by 24 by 3,600, which is 31,536,000 seconds, which I can write also 3.15 by 10 to the 7 seconds. So my energy emitted in a year by the sun will be the power, which is 3.9 by 10 to the 26, multiplied by 3.15 by 10 to the 7. So if I calculate this with my calculator, get 3.9 multiply 10 to the 26 by 3.15 10 to the 7. I find 1.23 by 10 to the 34 unit joules. This is quite complicated to write down in a calculator. So let me show you a simple way. Suppose that you want to calculate 2 by 10 to the 4. So what you would do is you write 2 multiplied by 10 power 4, right? 20,000. So you're writing 2 multiplied, then 1, then 0, then power, then 4. Right? There's a much easier way. On your calculator, notice, it's sort of like on mine, we've got the same calculator, I think. I've got exp here. This button replaces all that. Even the multiply. I can write this instead, 2x4. It's a much easier way to write down stuff, and you do much less errors. And when you do 2x4, it automatically, in the calculator, puts brackets. It makes it a priority operation. So, for example, in our case, if I want to calculate this energy, I type 3.9 E26 multiplied by 3.15 E7. And I get the same answer. So that's how you can enter in your calculator complicated numbers like this one. Okay, let's go back to the exercise.